Hi all. In this video, I'll show you how to move the cap lock indicator LED from the original position to underneath the cap lock keycap. Please watch my previous video for how to disassemble the Ducky 1 keyboard. Without further ado, let's get started with this modification. Alright, so now we have the keyboard flipped over, and this is the cap lock side right here, and the indicators right here. So on the bottom, some basics about this keyboard. For every single key, there are 4 pads underneath for the LEDs. So it is designed with RGB in mind. However, it's missing some controller chips, so it doesn't have RGB. We only have one chip here for the sync. So we're only using 2 holes out of the 4. And we notice that out of the 4 holes, there's one that's squared. This is the positive of the LED, and the circles are the negatives, and we will be using this one right here, the center 2 out of the 4. So this keyboard is configured so that the LEDs are sort of in a matrix form, so it could individually light up each one of them for a little bit of time and then move on to the next row. So that's how it controls to light up individual keys. Fortunately, for this indicator here and that LED there, they share the same drain, the sink, out of this one right here. So that's good. However, they don't share the same source. Fortunately, this source here is shared with the A key source here. So all we have to do is cut this trace right here so that this source gets isolated from the rest of the keyboard, and then connect a simple jumper from this one here to here. And then we will essentially move the source for this LED to the same source as the indicator over here, so that when the keyboard wants this thing to light up, this thing will also light up. Let's get started on that. Actually, there's one more thing we need to do before we start cutting the trace, and that is to make sure that everything else on the original source of this hole here are still connected even after we cut the trace, because we don't know if this is in the middle of the trace or if it's the end. Looks like it's the end because the trace sort of runs through here a lot and then comes down the bottom through some of the keys here, and the last one before hitting there is the C key. As we can see, I've set the multimeter to continuity test, so it beeps, and I'm going to touch that one and then the C source, and that beeps. So that's indicating that these two currently are connected together. So we're going to have to test that after we cut the trace to make sure that C key, so the C, B, M, this one, some of the arrow keys and some of the number pads keys, they are all still connected to the source even after we cut that. So we got to make sure that first. Alright, so now I made a tiny little cut inside this trace right here, as you can see. And for a simple continuity test between this key and the C key, we can confirm that they are not connected anymore. Now, to make sure that all the other keys are still connected to the source, we can go ahead and test the other keys that were originally connected. And for demonstration purposes, I'm just going to test those two, but I did test all the other keys on this side that's also connected to that one trace, and they are still all connected. So that's good. That means this was the end of the trace, and essentially by cutting here, we only isolated this one pad from the rest of the circuit. That's what we wanted to do. Alright, so now we're just going to add a little jumper between here and here. Actually, what I'm going to do first is solder suck these 2 holes clean, put the LED, move the LED from over here to over here, and then I'm going to connect from here to here. Alright, let's get started on that. Alright, so now we're going to remove the LED. This is the third one from the right edge. That's the cap lock. So I got a pair of tweezers down here holding onto the LED, so when I mount the solder points for the LED, I can pull it off. So what we want to do is heat up both of the solder points at the same time. So the LED becomes free. So sometimes when it's giving me a hard time, I usually just put some fresh solder on there because there is a flux in the fresh solder, so that would help with it melting. And there we go. So now we got the LED off. We're gonna stick it directly to the cap lock, but before that, we're actually gonna clean up the pads, just so we make the job easier when we want to put it back if we ever need to. Yeah, so as you can see, the new solder that I just put on there with the flux is much easier. Oh, that one, it's not working. Let's try again. There we go. So yeah, that's pretty easy to clean up. And now I'm gonna flip the board around and then put the LED back in it. So actually, one thing we gotta make sure when we put the LED in there is the polarity. So it's LEDs, they are light emitting diodes, so they only conduct electricity one direction. And we can figure it out pretty easily actually. So as we know on the board, the square pad is the positive, the circular pad is the negative. And as you can see, the LED, it's not symmetrical inside. So all we have to do is look at another LED on the board. For example, that one right there, and compare it. So from this direction looking, we know the square pad is to the right. Now if we look at the LED closely, see if we can get it to focus. There, that's good enough. The bigger section, the majority of the LED is on the negative side. So that we just have to keep in mind when we put this LED into the new location. Alright, so on the top of the cap or the keyboard, we can see that LED has positive to the right side. So what that means is we're putting this little bad boy in there, like that. Alright, so let's get started on that. Okay, so now we have the LED inside the circular hole here. I'm going to hold on to it with a finger and then flip the board over and solder it down. So we can see the two legs are pointing out right there. What I actually like to do is so make sure there's a little bit of solder on the soldering iron and then tap one of those pins so that the solder will stick it onto the board like that. And then now the LED won't fall off. So I can simply rest the board on something and then solder the other leg on. Like that. Right, so now we can go back and redo the one that I used the old solder on. There we go. And that's it. That looks like a good joint. So the last thing we got to do now is connect the source from this A key LED onto here. Okay, so here is our little jumper. Don't worry about the little longer legs. I'm going to cut that off after I solder it on here. So what I like to do is just put it onto where we want it to be. Right here. And just like that. The wire is not going anywhere now. So we can reorganize the shape of it. That's okay. And add solder to it. Solder it down. And that's it. So now we're just going to cut the extras off of it. Oh. Make sure you don't leave extra pieces of solder or wires in the keyboard, as that might short something out, and that could be catastrophic. Alright, so now we have the positive or the source of the LED all sorted out. There's something we also have to do with the drain, the negative side, that I forgot to mention previously. So as we can see on this side here, we have a focus. We have a 0 ohm resistor right there, that's R349. So that connects the controller chip with that pin there. On this side, we have the placements for the resistors, the R355, but there's nothing on there. So it is 0 ohms, so all we have to do is jump the two pads. So I'll do that with a short piece of wire. Alright, so in order for me to make that jumper, what I actually did was found a resistor lying around, made a really sharp turn in one of the legs so I can hold on to the resistor while I solder it down. So let's get started on that. So ideally you'll have another hand to hold on to it when you add solder, but since I don't, all I can do is put a little bit of solder onto the soldering iron and then quickly put it onto the board. So there we go, that's a pretty nice connection there. So I'm gonna cut the excess off of that. Good, and there's our jumper. Not the nicest looking thing in the world, but it'll do. Time to test the keyboard. Alright, so now I got my keyboard connected to a computer. By the way, be careful with that cable, it's quite fragile. Let's test this key. There we go, as we can see. When I press when the cap lock is enabled, that's the only thing that's lighting up on the entire keyboard. That means we separated the source and the sinks properly so that there's no other keys that is triggering it. The other thing we're going to test is by turning on the keyboard's backlight. As we can see, the cap lock is not on. That further demonstrates that we have separated the circuit properly. And turn it on and off. And to better demonstrate it, I'm going to put the keycap back on. And turn that off. Alright, so now we can see. So currently, the cap lock is off, and then you can turn it on, you can turn it off. Looks good. Alright, I think this mod is complete. Thank you for watching this video. Stay tuned for more modding of the Ducky 1. Take care. I'll see you later.